let's start at the first one. So, okay. The first step would be all about image capturing in 2D and 3D. Of course, if you do robot vision in 2D and 3D, the most important stuff is how to get the right image. As I told you about the hardware shortly, we support a lot of these options, and I will give you a very fast and quick overview about this. Then to understand what I will explain later about all the stuff about hand-eye calibration and so on. A short intro to the iVision software, simply that you know that you can follow what we are doing. We do it at some examples. Based on this, you will see how the project structure of the iVision software is, so that you can easily adapt and test it by yourself then. Then we will have a short look to detecting objects in 2 and 3D. Of course, if you want to do some pick and place, you need something which you can pick. Therefore, we have different algorithms, so we have a look at it. Also, these algorithms are used for the hand-eye calibration, so it's a dual use. That why it makes sense. First, have a look to the object detection before to have a look to the hand-eye calibration. Of course, based on this, we also do have a look to the image correction, because if you want to pick precisely, you need a precise image of the field of view on which you are operate. One of the next steps is how to communicate with the robot. Of course, there are a lot of robots outside there, and we try to support, as we do it, with all the kind of image acquisition hardware. We try to support as many robots as possible. For the moment, we have a short list of robots, but we made everything easy to adapt it to all kind of other robots, to increase the supported robots, or even to allow you as a customer to add more robots to the list of supported robots, so that it's not really necessary that we adapt each robot. Most of the robots have a standard interface, and with some text file you can simply adjust the communication, and then all the other stuff works always the same way, which I will discuss in a few minutes later. Of course, finally, we will have a look to a pick and place, some examples on the ready-to-use projects, and maybe some help and support. Maybe as an intro, I'm not sure if you had the option to look to our YouTube channel. There we have some nice videos about pick and place, where you can see how it works. We can have a look. Let's see. We can have a look. That was not what I wanted. Okay, so let's see. Maybe you know this or not. 1 second. So let's see. I simply recommend that you have a look to this channel, because you find a lot of information about it. And one of the interesting things is that we have also a short intro to robot vision. So this is a Nachi robot, where you can see simply application how to make it, which shows really good what we want to discuss about today. At the end, if you do it with gray or color image or with 3D, This short video gives you a good idea how to make it with the iVision software and how it looks like. So you see here one version in 2D, and a little bit later you will see then also for the same parts how to do this in 3D. At the end, for the end customer, you see only that the robot picks things. Of course, in 2D, it's better if it's flat. In 3D, it's nearly, you can pick it in any orientation. You have to do think about a little bit more about things, about collision and some other stuff in 3D. So this was only a short idea. Maybe if you have more time, there are also some other videos which might be interesting for you to have a glance at it. So maybe it's the first short intro. We have, as I told you, we have a really large instruction set in the software, and this allows you to do all kind of application. Then we have the standard 2D instruction set, which is valid for all kind of 2D cameras. This means starts from correlation, measurement, and everything. But we have also a real wide set of instructions for 3D. For both situations, we have different matching tools, of course, based on different images and different information. You have a different matching tool. And as I told you, you could also use our latest development, the deep learning matcher, which enables you also to recognize even difficult things. Our standard user interface, we had a look before at it, looks like this one. This is for the developer. Based on this, you can make any kind of custom user interface without these first two rows and all the decorations on the top, so that the customer doesn't have to see this. But here, the basic programming environment is on the left side, all the comments you need to make solutions. In the center field, you have the programming editor. In this case, it's an example for a 3D bin picking application. And here you see also the robot instruction set, which shows you the options, how he could grab and what the orientations are. And of course, you don't need it for the application, but you get also the visualization of the pick positions and the rotation and all the other stuff. We will have a look later to it. So this is similar for the 2D. Of course, in 2D, you don't have 3D coordinates. You only get the 2D coordinates, rotation, and XY position. You could also use this here as long as it's on a flat surface. You could simply use the depth image. Normally, we highly recommend to use the point cloud, because the point cloud has all the information about the object if you have a 3D application. For many cases, you don't need it, but you can always use it. So now maybe before we go deeper into the programming of the software, let's have a short look to the hardware. Of course, I know whoever was attended yesterday, he saw most of the stuff. No, he didn't saw the 3D, because we didn't have something about 3D. Today we have a very fast and close look only to the components. And okay, we need this. No, I wanted to have this one here. Okay. It's interesting. Normal. And I see the Foliensortierung. It's not believable. Okay, let's take this one here. It's too boring. What is the difference? Sorry, I don't know what changed between yesterday and today. I don't want to have this. I go simply through this a little bit faster because I don't want to wait for, I don't know what's going on. So let's discuss about the hardware very fast. Unbelievable. Yes. Smart camera. So you can, what I now show you is about 2D. Of course, you can use this robot vision feature with, of course, smart cameras based on x86 CPUs, or smart cameras based on, sorry, if you have a special, you have some special questions, simply ask me. I think for some it's boring. So you can do this robot vision, of course, with all these smart cameras also. And of course, you can do it with the small embedded systems. As long as you, of course, these embedded systems are mainly good for 2D. Of course, some of them could also be used with a 3D camera. Mostly, you need a very compact, small system, and then you can use also these embedded systems with a Linux platform and with the iVision, of course, with the robot vision software in it. And the connection, as you can see, also on all these platforms, there is an Ethernet connection, which is currently the main communication channel to the robot, or the main communication channel which we use to the robot. We also can support, of course, the RS232 interface, as long as the hardware platform supports it. All these platforms mostly have it, or you can add it based on an adapter. The smart cameras which we show here, which we saw here before, most of them have an RS232 interface, so that you can use the RS232 also, as long as the robot supports it. The communication is mainly done to the robot based on either XML or ASCII-based communication. So there is no real reason to use TCP/IP or to use RS232. Both is working, and at the end, it's only more a question of speed and what works better. Nowadays, if you use an XML, it's the best, as long as the robot supports it. As we saw here, we have these embedded systems, also like the Raspberry Pi and some similar things, or the NVIDIA board, especially if you have a more complex recognition task. It might be better to use, it's helpful to have some more support for the deep learning stuff. And in that case, we support either the NVIDIA, if you use an embedded system, the NVIDIA Tegra platform, or of course, if you can use a PC with, depending on the task, with some hardware acceleration based on a graphic card. For all standard applications, you can use any of these systems above, or of these embedded boxes from the different manufacturers. I think you know most of them. They are working very well. At the end, this year are PCs. You can use it either with Windows or Linux. As you know, we support with our platform both operating systems, Windows and Linux on x86, on ARM, MIPS, and RISC CPUs, RISC-V CPUs. We support only Linux. But for the end customer, you have exactly the same user interface, independently which operating system you are using, so that there is no real reason why you want to use Windows. Maybe because you are only allowed to use Windows in your environment where you want to use the system at the end. Of course, as the image capture platform, if you use the embedded systems, you can use only the supported camera interfaces. If you use the smart cameras, of course, the sensor is integrated. That's why it's a smart camera. It's any kind of either x86 PC with the sensor inside, or it's an ARM with a sensor inside. So you don't have to care about how to connect the sensor. In the embedded systems, you can use either the USB or GigE interfaces, or of course, for the moment, really fancy Midp interface. Maybe it will be also successful in the industrial environment. We do support Midp on all these platforms, so that you can build, let's say, very cheap hardware platforms to make solutions, also very small embedded solutions. On PC, you have either the chance to use USB or GigE interfaces, or if you, in case you have a high-speed need, you could use also QuackExpress and Camera Link or analog cameras. In most cases for robot vision, you can use with the standard. You can use a standard interface depending on the sensor you are using. But as long as you use 2D sensors, the robot is not so fast that you need any special high-speed interface. Of course, if you do 3D, depending on the manufacturer of the sensor, it might be or is necessary to use one of these QuackExpress or Camera Link interfaces to capture fast the image data to generate the point cloud. But we do support all these interfaces. That means you can use any of these PCs, and based on the interfaces which we support, here is an overview. You can select the camera which you want to use. Now I want to jump over simply to a short overview of the different cameras. Let's so I think this is maybe better. That is an option. So of course we support all kind of interfaces. As I told you, you can also use different boards and so on. At the end, you want to capture 2D data for your 2D robot vision, and therefore it's important only is there any restriction in the camera, and for the moment I can say there is no restriction. We support all standard manufacturers of machine vision cameras, so that you are free to select the right manufacturer, whichever you want from the list we support, and simply use this camera for 2D and as well as for 3D. Also, the interface wouldn't be real. Isn't a real problem. As I told you, we support from USB to GigE, FireWire, Camera Link, QuackExpress, and so on. So whoever delivers the best camera or smallest one, which fits best in your application, you simply can use it and makes a solution. Of course, nowadays we do not recommend the USB 2D. Normally we recommend USB 3 from whatever manufacturer you want to use. And here is only a short overview. Of course, you can also use DirectX or Video for Linux cameras. If you're on a Windows system, of course, the question is if it makes sense if you do robot vision to take one of these non-industrial cameras, but they are still available and supported with the software. and they are working. So currently these cameras are not so bad. Here is only a short explanation for co-express camera. The only difference is that these cameras deliver high resolution, high speed images based on the speed of the robots. Normally you don't need it in this high speed. Maybe if you need this high resolution camera. Or here one example of a Midp module. So as long as it's Midp standard, you can use most of the other Midp modules also. And more interesting are if you're doing 3D, the 3D cameras. Although here we do support all major manufacturers, for example, triangulation cameras or ready-made triangulation sensors. Of course, the triangulation is generates right now, for the moment, one of the highest resolution sensors for, let's say, the best price situation. The only disadvantage is the part has to be moved below the sensor to get an image, which can be processed here, as you can see here. Then you can use any of these sensors at the end. They simply generate a point cloud, or we get a point cloud in the field of view, and we operate on it. For smaller parts and higher resolutions, we have also some sensors. And I think more interesting, as long as the resolution is not so important, you could use area scan sensors like time of flight sensors from the different manufacturers, as well as these shape-by-shape sensors, which generate with a single shot or multiple shots one point cloud, and we can operate on these point clouds. So we also here we do support all major manufacturers and also some not so well-known ones. Especially we are just preparing a new one, stereo vision camera, which has a really interesting price range to make point clouds. But an easy entry would also be the Intel sensors, especially the LiDAR sensor has a real good resolution and speed for robot vision. But all the other sensors are as good as whatever you want to select. So the idea behind our strategy is not to press you in one corner to say, okay, you have to use this camera from this manufacturer. It's more, what resolution do I need to make to get a point cloud or an image which allows me to solve my robot vision task. So this was now a short overview about the 2D and 3D cameras. Of course, there are some others. If you're interested, you can download this presentation and have a closer look to all the different supported cameras so that you see what fits best for you. Or you can use any of these smart cameras which I showed you and use it with the reduced or instruction set for example, to do 2D matching with the robot vision instruction to communicate with the robot. Then you can use the vision sensor iSense RV, so you can make from each of these components as a robot vision solution. So what's important if you want to do a robot vision? As I told you at the very beginning, we do need some matching. Of course, we have different matching algorithms inside, and the other step is to have a good image. And here you see we have this distortion correction. So we will have a look how to do it and how to do the distortion correction. Of course, the best thing is always to have a non-distorted image or you use a lens with no distortion as long as it's possible. Anyway, it's always good to have a very good image correction so that you operate on the best image. Based on that, the pick and place works best. What tool fits best for the task? Of course, for normal shape tools, a shape-based matcher like the key match here would do the task. We saw it also in the video which I started a few minutes ago. So the matching tool detects the object, generates then the coordinates. You can see it here as a result. The resulting parameter which can be transferred to the robot. The only thing is then, of course, you have to do in another program the hand-eye calibration that these coordinates are fitting to the robot's coordinate system. That if you give the robot a coordinate, he has the same, he can use the same values based on the registration. The same situation is here. It's so you can see the data somewhat better. You can see we have a look to this command how it works, and you simply get the information, and after the hand-eye calibration, you simply send it to the robot. So the difference between the 2D and 3D is on one side you have the point cloud. It could also have any orientation in the field of view. Of course, if you have a 2D, you don't get the room axis, so you have an X, Y, and a rotation. And here you get X, Y, and Z, and all the angles, so that you can grab it. Therefore, the matching is a little bit more different, and based on that, you have different pick options, which you can detect based on the orientation in the 3D area. So let's have now a look to the iVision software. So that we not only have a theoretical look to what's going on or how it works, that we have also see real images or real thing. Yes. Let's have a close look to the software first. Then I don't have to explain everything later. The important thing is you saw it before. The software has to communicate with the robot, and the data have to be processed before. So for the robot communication, we have a robot communication instruction, a tool. And for the data for the pre-processing and handling, there is a structure. So we are here. So you see this. This is the, let's say, the string pre-processing display. So for all the data which are generated in the software, you have these viewers that you have an overview about all the data which are generated, and which you can use then later if you operate on them. Let's add one additional tool. So we start with the 2D and go then to the 3D. So I switch off the 3D register set because it's only needed if you start with a 3D. We do some 3D stuff. Of course, so we have these, let's say for the moment, these 3 registers. Let's have a small discussion about registers and what they are, what they mean. The tools in the software communicate always over these registers. The registers are their main communication infrastructure. This means if one tool generates a value, it passes it to the other tool based on the resulting registers, resulting data, not registers, of course. So, we will have now a short look to one of these. Let's have a look at one of these. Someone took my part away. Anyway, seems someone want to make me a little bit angry. Anyway, let's take a special part. Sorry, I just had a small problem here. I would say I have to make a short break for 5 minutes. Please stay tuned. Maybe you have also the need for a restroom or so. I'm back in 5 minutes. Thank you very much. Sorry. So sorry for the short interruption. Now we are on a good condition to proceed. Finally, so sometimes things happen. I hope everybody is back again and is ready. So we stopped about discussion about the registers and what the tools are doing. As I told you at the very beginning, of course, the software has different tools to do matching and or to matching, detecting objects. This is mainly important if you do a pick and place. You have to know what you want to pick and how to do it. If you do it in 2D, mainly we could recommend the key match. As long as you only need a XY offset, you could also use the object count. Basis for all these matching and robot vision is that you do a hand-eye calibration, which we have a closer look later because it's a little bit more complex. How to do it. And but let's think about, let's have a short idea about the, or a closer look to the eye vision software, that we know how it works as the basic to understand the rest somewhat better. So how does the software work? In principle, of course, you do an image capture simply by using the image capture command, or if you only need a live image, like here, you simply use the live button. And so, of course, now you ask, okay, what camera can I use? Of course, we had a look to the supported hardware, and as maybe you remember or you don't remember all of them, I think it's not really necessary to remember all of them. You can go to the application parameter after installing the software. By the way, I hope everybody from you have downloaded or has at least a link for the download of the demo software, which allows you to test or try out everything what I show you today by yourself. So even with the demo version, and you can see here on the bottom right side, you see here demo. So I also use the demo version. That only that you see, you don't need a full version to see if you can do something with the software, especially bin picking or whatever. You can simply use the demo version and operate with the demo version. And as you saw, this is a live image. That means also with the demo version, you can do the test with your demo version. What you can't do, of course, unfortunately, is to do the full test of the robot vision. This because you have to communicate with the robot, and of course the communication is also working in the demo version, but not completely, which results in we don't transfer all the stuff to the robot, and that's difficult if you do robot vision. But I think you can see the pre-processing of the data and the preparation of the data. And then I think if you see it once that it transfers the right data to the robot, you can imagine if you have the full version, it will do it also with the full version. That's why we have opened here the global string viewer. Here at the end, you see the communication results, which is sent and transmitted and received from and to the robot. And therefore, you can see everything in the global string viewer. Of course, not all you see here in the global string viewer, if you're in the demo mode, is transferred to the robot or to any other machine. So we have this restriction for the demo version, not only for robot vision, also for all other machines. This is a kind of software protection to allow our customers to test everything. But of course, if you want to use it in a real machine, you need a license. So let's have a look to the hardware. If you have downloaded and installed the software, you simply go to the application parameters, and then you get this menu. There you will find the hardware configurator. So in this case, we say for the project, you can configure the hardware for each of the project. What is a project? Give me a second more and I explain you also what the project is. But here for the first entry, you see here the list. This is the same list as you saw in the presentation. Of course, you can get also the hardware presentation. This is the same list as you saw in the hardware presentation. And if you have, for example, I don't care, whatever you want to use, maybe Allied Vision, you want to use the Allied Vision camera, you simply click to the Allied Vision, and here you get a description how to install the iVision native driver to use the Allied Vision cameras or any of the others. So normally, if we support the native drivers, we recommend to use the native drivers because they are always a kind better than if you use the GeniCam interface. Of course, you can also use, as you can see here, GeniCam to communicate with GeniCam compliant devices. If you use the driver from, or you use it from Basler, the Pylon, you can use all the Basler cameras and all these neat little features which you might, which you don't have access maybe over GeniCam or not so easy or whatever. So simply you select whatever camera you have, and after you followed this instruction on the right side, you can use the camera even with the demo version. Also for 3D, you find here all these 3D cameras, so you can operate and do everything also with 3D. If you have selected the camera, you simply can start working. If you don't have any of these cameras, but you have maybe the built-in camera of your laptop or a similar USB camera, which you have for a video conference, you simply can select Direct Show on Windows, or you can select, if it's a Linux installation, you simply use Video for Linux, and you can use the USB cam for your first tests. Of course, we don't really recommend these cameras for production use, but for your first steps, it's always good to use it. So if you have now a closer look to this one, this is also, let's say, a webcam. If you have after you have selected it and the camera is connected, you can have a look to the camera settings, and there you will see then immediately camera settings dialog. What if the camera is there? So you see it's called video input channel 0. There it's Dinolight. This is a microscope camera which you can buy. It's more industrial usage for kind of industrial use camera. It's nice for small presentations. Anyway, so you see here the camera. If you have a GeniCam or GigE camera, also you have much more parameters here. You have only the main parameters which are necessary to do some image capturings. And of course, you have full access to it and you can assign it. If you have multiple cameras, you, of course, here we see we have 2 Dinolights. You can have multiple cameras with multiple devices. And the software automatically finds all the connected cameras at the system. And if you do real applications, sometimes you want to assign the position of the camera to their locations in the main memory, because one position is a device which captures images into the main memory, and the other thing is where the images arrive. In this case, they arrive in image memory 0 for for camera 1, and maybe for 2 in image memory 1, and so on. But you want to be sure each time you start the software that if you have multiple cameras, they are connected to the same image memory. So you have the option to assign them to each image memory. So maybe you have one camera in the robot hand and the other one in the overview. Then you could have the robot hand in 0 and in 1 the overview camera. Of course, you want to have it always the same in the same way, because you expect the images in these image memories. The software works always on image memories. That's why they should, the cameras should deliver their images, either if it's a 2 or 3D image, in the associated image memory. And of course, you do not see here image capture 3D or whatever. The image capture tool automatically detects what kind of camera is connected. If it's a 2D camera, you get a gray image. If it's a 3D camera, you get a point cloud or depth image. Or if you have a camera which delivers multiple data streams, like the RealSense cameras, you can get the point cloud plus the color image plus, whatever it delivers. So that you can operate on these different data streams. That's why I discussed about data streams when we had a closer look to it. So let's start with our first steps in usage of the iVision software. So whatever you need. So here we see we have an empty CKP. Maybe we make a new one. So it's unnamed, and the programming is always the same. You simply take a comment from here, drag it into the comment column and release it, and immediately you get the configuration for this image capture. Depending on the camera and what the camera can do, you can select flash, or you can apply a trigger or whatever. For today, we only need this capture image now. And then we have our first, let's say, program. If we run it, we see, okay, it captures images. That's what we need. We don't see any result here. Of course, the camera, we could see something. We capture an image to image memory 0, but we see it here in the view. To see something in these result images, no, I don't want to do it. I want to have a more easy, I wanted to use this one here. If you want to have some results of it, we could use, for example, the blob tool. Later we have a look to the key match, and we say, okay, we want to count the number of white objects. So we simply select this, we select the color, and we do a test. And finally, if you have a look now to this, we see immediately for each for each execution, we get now the position of the object in XY position. Of course, it's an object tool. It doesn't get the rotation. If you need a rotation, we use the key match. But the most important thing what I wanted to show you here was the tool automatically delivers the position XY on in the point register, because it's a point, of course, and it delivers in the value register how many objects it found. It's an object count tool. That means if there are multiple objects, it would also, we would get different numbers and also got different objects. The latest active is always red. So we see the result of the tool is always on top of the register. This means if you need it to send it to the robot, for example, the position here, the robot command could automatically simply say, I take the X and Y position from the top of the register 0 after the execution of the command, and I could send this to the robot. How we do it in a few minutes. So, but the important thing is, now I think you understand how it works. The software, each tool generates the resulting values on these registers. That's why I opened it. So another important thing to understand is the project section of the software. I didn't mention it now, but it's in the next few minutes we will have a closer look to different projects. And this is also a very powerful thing if you need support from us, because we are happy to support you, but we need the information if we have to support you. So therefore, but also we assume you do different, you make different solutions in the average with the software, how to handle all this data, that you can retrieve it again if you want to do something else, or if you have another customer with another task, or you built another machine with another task, how to hold all this stuff together, that you have for each customer everything ready, and you can also save it and store it anywhere. If the customer calls you, that you can also after years recap what you have done. So for this, and this is now a feature which will help you, which will be very helpful if you need help later or whatever, or in your daily life, it will help you. We have the project feature. What means project? Project means this is a folder where all the stuff is stored, which belongs to one setup from camera, images, calibration stuff, website. If you have a web, the software has a web server built in. If you made a web view for that, for solution, everything is stored in this project file. So therefore, let's make our first project for today, and we name it Web Robot Vision 2D. So if you have a look now to the left top corner, immediately you will also see, no, we don't want to store it. Now the software goes in a basic situation, so everything is reset to start, and of course the software has now a project. It's called Web Robot Vision 2D, as we named it. So if we have now a look to the data directory, this is where the iVision software stores everything. We have a project folder, and in this project folder we find this Web Robot Vision 2D. Here we find it. You see here some others. If we go inside of this one, you see here immediately, yes, we have here some bitmaps, data information. Most of this stuff is right now empty. Documentation, we don't have a documentation and so on. But if we start now with some work, or especially whatever you do, everything is stored here. So if you have some robot data which you want to retrieve, you simply find the robot data here in the data folder, or if you have calibration data, you find it here. So maybe you think, okay, you know now why where this folder is. It's in program data. This is a Windows standard folder. Normally it's hidden, and so on, and projects. So of course this is a hidden folder. That's why we have this this show data directory, that you don't have to activate the unhide option. But more important, on Linux systems, the folder is totally different. So it's more difficult to find it. That's why we have this easy option. But how would it work now? Let's say we do the same thing as before, and we do something different. What we recommend always. So we start with this image capture tool. Okay, this is what we saw. So we capture an image. And what we also can do is, with the capture tool, you see always the tool has different options. We can save images, or whatever images, 3D, 2D, color. And if you have a question to us, you can always get help from us. But in most cases, we need some images on what you are operating on. So we recommend to store 2D to save a few of the images that we can whoever should give you support have the same situation and same information as you have. So in this case, we say pet object, and we use JPEG. In most cases, you could use JPEG files only if you have a high accuracy project where you want to, and you have problems with high accuracy measurement. We would use a lossless storage format. In this case, JPEG is good. And so each time if we run the program, so now I move the part a little bit and run it again, and run it again, and run it again, and maybe I do it once again. Okay, I want to have an image in the so, and run it again. So once again, here you see now one of the limitations. So all, as I told you, all the communication functions, also save stuff is a communication function. That means the last image wasn't stored. So we tell you, you try to store an image, we didn't do it. So if you have this, and if you are programming, you simply say, okay, store it again. It's not a problem. If you're in a live process, this wouldn't be very nice if you miss the not good part to store it. So that's but this is only a small restriction. So if you have now a look to our folder, maybe before we have a look at it, we save it as save this image, this program. Yes. So, and if you now have a look to this folder, and we look to the programs, we see in the programs folder we have this capture save, and in the data folder, not in the data, in the images folder, we stored it in the images. We stored now these different images. That the advantage is now you have the option, if you need some help, you can send us this project completely, and we can see exactly what you have done, because the program, everything is here, and we can tell you, okay, maybe that's a problem, or you could do this or that, because we have exactly the same images. That's why we also recommend always to store some images from the real machine or from the real situation to get the best support we can give you. After all, it's also good for you if you don't want to sit all the time beside the machine. You can store based on this kind of capture and store some images, go to your office and do all the programming without sitting around the machine where maybe it's somewhat loud. So now we have this image, and we could, the advantage is now, of course, you have, I think you guessed it, you can do also a cyclic read. That means we go to the store, select this folder, and if we run it now, we see each time the program is executed, the part is reloaded, and you have exactly the same situation as you have the camera. The only difference is, in this case, the images are not captured from the camera. It came from the file. So, and of course, you can save it also as load and execute, or whatever, however you want to name it. And the good thing is now, if you have a question, you simply send us the complete project folder, and we have all the stuff, also the calibration and everything. So with the download links, you should also have, now I can discuss this before we go ahead. You should also have all these different downloads for all these kind of examples. So for example, you have for 3D here, the bin picking example. We can open it in a second, or we can open it right now, which shows you always how things, how we operate, how we do solutions. So let's go to the 3D area example, bin picking as example, and we open the project file. And unfortunately, it goes to the wrong display, but I simply shift it over here. And you see here, each time now, if we run the program, you see here, we load a point cloud with the different objects, and you see also the 3D matcher, in this case, the 3D matcher. So you can see here the summary. This is only an example. You can see here the summary of the found objects, found object orientations. And in this case, we have also the necessary grip space for the tool. So of course, you can right now with the current gripper, you can only grip the parts with where you have the necessary space on top of the part to grip it. And of course, we grip not everything, so it's only a short idea to see it. And the main advantage is if you want to start and do something, also robot vision, you simply can use these ready-made projects so that you can see how we made it, and you simply can adapt it to the needs you have or to your tasks. So let's go back to our small demo and have a short look before we go deeper inside of the robot vision to what we have done. So this is the last program we used. You saw just before that we had some different views on the screen. You can define what you have to see or what you will see when the application starts up. Therefore, first of all, you have a user interface builder, the layout editor, which allows you, for example, to select any kind of background. So we automatically deliver one background. Of course, you can change it to your own. And you can save also these backgrounds or these user interfaces with different names. So normally I always use one developer's view, where I put everything together which I need when I do some development. So as we saw, okay, we need maybe the global string would be very helpful because we do now 2D. I would say also the value register is interesting, and because we want to have also a point, then we take also the point register. So we can override the dev view now, and he has now recognized this. So you can always open up this dev view, either if you select it here, or if you want to be sure that if you open the project, you have always the same things. You go to the application parameter and tell the software how it should start up, and with which view it should start up. So normally you see it from the old one. We start with defined program. So we start always with this one here. We run it once so that we see something. And the other option is now you can select the display, apply, yes, of course. And we keep the language which we have activated. So if you want to start with a special language, you can tell him, look, you have to start with a Japanese or whatever. And we want to start up with the defined project. And in this case, we want to start up when the software starts with our robot vision project. So, and then we need additionally the program control, apply, of course. You should always press apply if you have different settings. So you can now adjust for each project all the different views and all the settings. So we store now for this project what camera is used, on which image memory is the camera. So if you have multiple cameras, it's important. Where is the for example, TCP IP hardware do you use for the project, and everything. So of course, now we are where we was before. We could simply go back to we had the object detection before. So let's say now this time we use our matching tool, contour matching tool. So if you have a non-symmetrical part, you could use only a fraction of the part. Yes, for example, this one. So you don't need to match the complete part. We for example, search for the complete part, or you can give him the complete part. Say, okay, we want to have this one, and we name it my pattern. Maybe you need some other patterns later. And at the end, you get the center point. And of course, it would be also interesting because we do robot vision. We want to have the orientation. So you don't have, this is only the print. The values are automatically generated and stored, so you can use it always. That's it's not necessary to display it. It's only for today that you see how it works. So, and finally, you could also say, I want to have an anchor point, and Normally centered is very good, but if you, in this case, the anchor point is this point of the part. This is the point which we return. That means if you have a gripper which fits best for this, you have to change this position, the anchor point to the position which you want to give back to the robot, that the robot has the right grip point. In most cases, it depends on the gripper. So now you see here automatically we get the XY position, the anchor point, and we get the rotation of the tool. Of course, we have one object. The key match can also find several objects. So if you have, you saw it in our intro video, if you have multiple of the objects, it would find multiple objects, and you could go through these objects and grip them. If you have only one object in the field of view, of course, then you don't have to do that. Anyway, you know how many objects are found. As second result, you find the rotation, and then you see you find the anchor point. You get also a second point. The second point is the front point of this arrow. Yes. So this also generates your orientation. So if you if it's better for you to get an orientation point, you could use the second entry here. So you have the anchor point here and the orientation point here. So this is all you need to do robot vision in the primary. The next big thing would be the hand-eye calibration. Maybe also a short, now you saw this. And so how do we bring this data into the global string? Simply by using the communication instructions. Of course, there are different ways to do it. There's a graphic way. This would be the global string tool, or there is real powerful way, which you should always consider, because you could prepare immediately also, depending on if it's a supported robot or a non-supported robot. If you have to prepare special strings for this robot, you could always use also the script interpreter. What does it mean, a script interpreter? The script interpreter is a similar tool like this here, but you can program within the script interpreter in a basic syntax. So you have the option to program by yourself, especially in generating strings or handling strings, which is in many cases necessary to generate the robot output. String handling is a nice thing. It is much easier if it's complex, if you do it with the script interpreter. The script interpreter is really powerful because it has full access to all to all the internal variables and information of all the tools. So you have full access, of course, to all the registers, no question, but you have also access to all the tools parameters. That means if you have a look to the parameter list of the tool, in this case the 2D matcher, you see here the resulting, for example, the minimum, maximum angle, the anchor point, and so on. You simply can click to this one, and you immediately get this script snippet, which allows you, which you can copy from here into your script to access these parameters, either to prepare your output for your robot vision task, or whatever you have to do with it, or if you don't find the right pattern or whatever, you have full access with the script interpreter to all kind of stuff of the iVision software. This is really powerful. But for the short demo now, you will see we could also prepare, depending on the robot. I will show you in a few seconds one example for the Nachi robot, but there are some others. So it's enough if you say, okay, we want to enter some stuff into the global string, which we will send later. So you will see it later. You see there is a, I use exactly this one. This robot says, okay, I want to have 4 if you send me a point and an orientation. This comment is 4. You can define it there. And then you need the value. In this case, we want to have the angle of the object. So we use the 26, and of course we want to have the anchor point. So we go to the anchor to the register and use the anchor point here, and we could do separations. We could separate it by commas. In this case, we don't need this one here because we have selected here. And if we finished and we run it, we see here we have 4. So now the comma is not so good because we have the English notation. Let's say we use this semicolon, then it's clear. Okay, and of course, if you operate on it, this is a collecting tool. You have to reset it at the very beginning of the program or whenever you need to start with a new. So now we have the command 4. We have 0 orientation. Let's go one more. Then we have the orientation. We have 17.85 as the rotation, and we have these 248.35 as X and as Y. You could also have 3 digits or whatever you need. So in principle, you could now we are ready. And if you have a very simple robot control, you simply could send it out to the robot by simply send. And if you have the robot connected to a TCP IP or UDP network, you simply take the IP address, and that's it. So you can simply send out this position. After you, of course, the first step is always the important step, is after you have done the hand-eye calibration. So I think the one of the important things what I wanted to show you here was first of all, let's save this one as a demo. So now we have this find object and transfer position. And so maybe you say, okay, only to explain once again why it's helpful if you have questions now, whatever. If you have now saved stored the images and everything, so all the information we have generated now, it's not so much, but we have the images and we have the matching pattern and everything. So if we go now to our projects, to this one here, and if you see into the data directory, okay, there's still nothing. We have in the image directory, we have the reference. This is the pattern reference image. We have our images here. And the longer it takes, and of course we have these, we have our programs here, find object and transfer. So if you send this project to us, of course, we can help you because we have all the information we need. If you also have done inside of this here, the distortion correction and everything, we have also this distortion correction stuff already made. And we can have a look to it. So maybe a short look. Sorry, I just missed something. Oh, 1055. So phi represents angle. Ah, sorry, I didn't saw the question. Phi represents the angle, right? Yes. In this tool, yes. And maybe you should take the hand symbol or switch on your microphone and say, I have a question, or there is a comment because I didn't get any information. And so I just saw now this the short information finally you sent me. Okay, so yes, before we go ahead, a few short comments again. So this is a programming environment, and here you do the programming. Of course, you saw now we run it from the stored images, but you could also do it simply. We take this tool that we disable this one here, and now if we run it now, you see it's working. But of course, I will move it a little bit here under the camera, and you can see it's live. We have to stop. We have to deactivate this one because the IP address is not correct, and of course, that you can read it here, we need here a short delay because we overwrite it here all the time. You don't see it. That's the problem. So if we do here a short wait, let's say 500 milliseconds. And then now you see if we move it, now we can update it, and you see the values are changing exactly as long as we can match it. So, okay, so let's save this. So what we recommend also is you see here, we have this comment section only for or whatever. So we recommend to add also some comments that you know what the thing is doing. Here, find the part or whatever you think, or here, add pause and handle. That's what we recommend. As in all programming languages, it makes sense to do this. So from 2D images, EVT process pattern image and get center point XY regardless of orientation. What do you mean with this comment? I got the, this is what I understood so far. Okay, with the pattern matching tool, you have the option to match these patterns or find this pattern in the field of view, and based on the trained orientation, we return the offsets. So related to our basic coordinate system, as long as we don't have hand-eye calibration, we return the result to the upper left corner. And of course, based on this, we deliver also the angle related to the to this trained position. I hope this was the answer to your question, right? I got this question about it. So this is what we generate here and what we store here. So and because you can define the anchor point, this means this one, you can set it also here because maybe you have a suction gripper which needs this complete area. You can position the anchor point. This is a returning point of the this function you get this, you get then the anchor point and the orientation, so that you know exactly when you grip related to your gripping point where the rotation of the part is. Yes, if you have other questions, let me know. What I wanted to just discuss, and only as a side effect. So, of course, now we capture the images as we saw it from the camera. Now this is a live image, more or less live, because we have this 500 milliseconds here. If we switch this 500 milliseconds off, then we see, okay, it's live. And what's interesting, what's interesting is you see here also the time which is consumed from each tool, so that you have an idea how long it takes if your hardware is fast enough or not. So sometimes, of course, it's difficult to handle this. It's really nice if you can switch between capture image to capture from file. So we have always on these columns different options. You get these options if you press the right mouse button. Right mouse button is always a good thing if you want to see it. And here you can see, you can execute these different commands depending on you do it never. This is what we have now, or always. This is this one. Or you say, I want to do it in, this is snap from camera, in process mode, and I want to do this here in configuration mode. So now we are in process mode. Let's go to the configuration mode, and DP, what is this? This is a process mode, okay. And this here is the configuration. Only in configuration mode. This is debugging, this was wrong. Only in process mode, this is the right thing. So, and now we are in configuration mode, so we load it from file. And if you're at the machine and you're in process mode, then we do it directly from the camera. So this is a nice option, and you see here from these ones also, if you are doing some debugging stuff, it's always nice if you want to see output or some stuff. You can say in debug mode, then you can hold up some stuff. So for example, so we go to owning configuration with debug. So we go to configuration mode, and now you see we have this delay inside because we are in configuration and debug mode. So this makes things easier to switch between different levels, so you don't have to always switch the symbols here. You simply can handle it by configuring these labels, which enables you also at the end the option blah, 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 what I want to say, yes, which enables you always the option also in the real final solution. If you switch in your programming environment, you simply have the option going fast to see debug outputs without changing anything in the program. Yes, so finally, I think we saw this, and we have this project. You saw how this works. So let's have a look. I see it's 10:51. We have a look to some other projects, and one of these I recommend for you to have a look to all of these. Here in 2D area, you find a lot of interesting work which helps you to understand how it could work. And in the robot vision section, we have here two nice projects which enables you, gives you a short intro in how to do this. For example, distortion correction. And now here you see, this is an overview how to make this distortion correction. So you need a chess pattern, and you should have at least 10 to 15 patterns in your field of view to do a good distortion correction. As I told you before, of course, the key match works without distortion correction, but because you have at the outer part, yes, depending on the lens, if you have a bad lens, you would see immediately you have a distortion outside of the center. And this distortion is depending real significant, which means at the end, if you don't do this distortion, the camera sees the object at a different position as the robot assumes it, because the robot coordinate system is always flat without distortion. So that's why it's really necessary that you do a distortion correction at the very beginning. If you don't do the distortion correction, and if you need an exact gripping, then your gripper grips maybe, depending on the distortion, a few millimeters left or right. And then if you have to place it at an exact position, you have the wrong grip position, you have the wrong place position, because it's if you have an error in the grip position, you have then also an error in the this was not what I want to have. Let's stop it. In the place position. And so here you see what we did before. We do now the image capture, and of course we have here the distortion correction. As always, each tool has different option. In this case, we use this generated distortion correction to do the correction within this field of view. So the image is captured here. This is a distorted image, and the next step is the image is corrected. So in this case, the lens was not so bad, but anyway, there was a distortion. So you have to do it at the end. The next step is, as you can see here, we use this key match tool. And of course, if you want to have a look to it, what the result is, you can I think now you know it. You activate the point register, and you activate the value register and point register. Then you see here the resulting value of the key match, and at the end you get the orientation angle and the XY position. This is how the robot expects to get these the data. So in this case, we do the preparing of the data fitting to the needs of the robot. Of course, I said the Nachi robot has this simple format, or can use this simple format. So, for example, if you have a look to this one here, you can send him a point in simply by separated by commas and points, to move the robot and do some interaction with with the robot. As I told you, what I described before is, first of all, you need that the distorted image, however distorted it is, should be as flat as the robot coordinate system, and the robot coordinate system always expect it's flat. So you do this distortion correction, and then you do the communication. If you do it to a Nachi robot, in this case, you simply have this for as a communication command. Of course, you do this on the other side. In some other robots, as the example from here, you have you generate this robot calibration text where the description is how the robot expects it. And in this case, he expected as an XML struct. And the struct is generated based on the key match resulting values and this command, which generates automatically out of this tool the resulting ASCII structure, XML structure, which have to be sent to the robot. This depends always. That's what I told you at the very beginning. This is the advantage what we have. You can design this this output structure simply in the robot description, so that at the end you don't have to. You can use ready-made descriptions, or you simply say, I want to use these predefined communication structs which we made for these for some of the robots, or as long as it goes, as more robots we will support with this. So if you do it for a robot which we don't support and you want to help us, we are happy if you can send us this. Here is another question. You mean calibration is important to understood distortion is in case camera is mounted on the robot? Independently, yes, calibration is really important in any case. The distortion correction generates also automatically calibration. It's based on the pattern we see. We know the pattern, and based on that we can calculate the calibration. And this is important also if the camera is mounted on the robot, because the camera is always a similar distortion. Of course, if you place the camera to the robot and you have it in the center field, the distortion is, you have the field of view of the camera in the center field and, of the robot gripper, then the distortion is not so difficult. But at the end, because the runtime is not so bad, you see it's 23 milliseconds, even on this PC, and this is not fastest one, it's somewhat old laptop. You should do this in any case to have a flat coordinate system, which fits to the flatness of the coordinate system of the robot. So this, I hope this answers your question. Yes, so unfortunately, so you see these comments, and you simply can add, you simply can select one of the supported robots, or you generate this communication structure for the robot you want to use. Or if you cannot do it, you simply give us this communication structure and we can help you to generate it for the software. That's not a big deal. So now we spoke a lot about 2D. Unfortunately, time is running like hell. I would open up for the end also our 3D robot vision example. I think we saw a 3D a 3D matching example. So you, of course, if you have downloaded it, you have it on your side, so you can use it always. So here, of course, again, you see here, these are the comments, and here you see this short example. And for all things you want to do, you can download also this example and have a look by yourself how we did it. And here you see exactly the same. Of course, the communication. I think this is the old one. Yeah, anyway. The communication is generated in the same. In this way, in this case, we have additionally through the XY, we have also the different axes which we need if we operate on a 3D part. Here you see the calibration point of the robot, and so we have here all kind of examples to operate on it, on this, that you can have a look by yourself how these data are generated. Unfortunately, I have to leave you now. If you have any additional questions, I simply recommend you send me a mail. I mean, 1 second, in case camera is more than, so this was the question I answered. So if you have any additional questions, I would recommend you send me a mail and I will answer you. If you have any specific part you want to solve, I showed you, you can store some of the images and what you want to do. And then I can show you based on your parts how you can do it with the software. I think with the demos, which you can download from our download links, you can get, I hope, an easy access. But before, if you have any problems or you are at a position where you think, it's not working or so, and it takes too long, feel free, write me a mail or write a mail to support@evt-web.com, support@evt-.com, and you will get an answer very soon. Of course, as I mentioned before, that's why I really took care about how to make a project and so on. It would be really helpful if you can send us not only a question, if you can give us also some images and what you want to do, or maybe how you tried it based on our ready-made projects, so that you can that we can give you a detailed and focused answer to your needs. Unfortunately, I have to say, I hope it was somewhat interesting. I tried to make another session about 3D, where we focus on only on 3D pick and place, and maybe also a smaller section of 2D, because we made a lot of 2D today, but 3D is unfortunately only at the cornerstone. But I think you have all these different projects, and you have these robot vision projects, but also the example projects are here, which belongs to bin picking and so on. I hope I can see here soon from you. How much does the basic version cost? The basic version, there's a question, how much does the basic version cost? The basic version costs about 1,200 euros. Yes, I thank you very much that you was here. And also, if you have any kind of these questions, simply write a mail to me and I answer it very soon. Thank you very much. Have a nice day and a nice weekend. Bye-bye.